In this video lecture, we will study motion of objects under gravitation force. Okay, so basically, we will look at some of the examples of free fall, and that will try to help us understand more about how does objects behave under free fall. Okay, now we know from our previous lectures the equations of motions, which is v equal to u plus at. That was one of the equations we looked at. S equal to ut plus half at square, right? And then v square is equal to u square plus 2as. We looked at all these three equations of motions before, right? Where v is the final velocity, u is initial velocity, a is acceleration, s is displacement, and t is time. Okay. Now, in the free fall, or when the object is under gravitational force, we use g instead of a to denote acceleration. Okay, so another point to notice is the acceleration direction. Since velocity and acceleration both are vector quantity, you have to be consistent. So the typical convention is if the object, let's say the object is moving in this direction, right, then velocity of that object, we generally take it as a positive. And if the acceleration is acting in the same direction of velocity, then acceleration would be positive. If acceleration is acting on the opposite direction of velocity or opposite direction of motion, we take acceleration to be negative. Okay, so if I look at this one, an object here is falling towards the earth, the acceleration of that object would be g, right? We know that. So if the object is moving downwards, and this is just a convention, it might change. You just have to be consistent in your problem, right? If the object is moving downward, the motion is downward, the velocity is downward, then I would assume g to be positive 9.8 meter per second square, right? Let's say I did a problem in which I throw a stone upwards. Okay, now my object is moving up, my velocity is up, so my g value would be 10 minus 9.8. Now this is more like choice. So as long as you state in your problem what is your plus sign denote, what's your negative sign denote, you are okay. But this is typically the convention. If the acceleration is in the direction of the motion, it is positive, and if it is opposite to the direction of motion, it is considered negative. Okay, now let's look at problem here. So in this problem, they're saying us there is a car which falls off an edge and drops to the ground in half a second. They also gave us the value of the g. They're saying use 10 meter per second square. So we calculated the value of the g to be 9.8. They're saying use g equal to 10, and this is basically for simplifying the calculations. So in the problem you will see many times that they will provide the value of the g, and then you don't have to use 9.8. If they don't provide anything, then use 9.8. Okay, so now the first problem they're asking is calculate the speed of this car when it strikes the ground. Okay, so well, if you just look at, just draw this out. I have a car, okay, and then it is on the cliff, let's say here, and then this is probably the ground. It falls off, it hits the ground in like half a second, right? And because there is a force here, which is g, acceleration is g, and I need to calculate when the car hits the ground, what is the speed. Okay, now so to solve this problem, first one, we know that car takes about half a second to go from to reach the ground, right? And the initial velocity u of the car is 0 because initially the car was actually at rest. It was just standing there. Acceleration, which would be g here, is going to be positive. Instead of 9.8, I would be using 10 because the problem says use 10 meter per second square. Now you can say it is downward if you want, just so that there is no confusion. But because the car motion would be downward, acceleration is downward too, so they were in the same direction, so use positive. Okay, now we have the formula, right? V equal to u plus at, okay, and v is the final velocity. So if I put all these values here, so u is 0, acceleration is 10, and then my time is 0.5 here. So what this gives us, like the g is basically 5 meter per second, and that is the velocity downward. So that would be downward, but the problem is asking only the speed. The speed would be magnitude of this, so it would be 5 meter per second. Okay, now the second part of the problem is calculate the average speed of the car during the half-second journey of this car, right? So we know average speed, this is the second bit, so average speed is going to be initial speed plus final speed divided by 2, right? That's the average. So since we know final velocity was 5 and they're asking the speed, so I will just take the magnitude. Initial speed was 0, taking half of it, so I get average speed of this car was 2.5 meter per second. Now the third problem in that question was, how high is the ledge of the ground? Is the ledge from the ground? So basically it's asking us this distance. Okay, so and that's the distance which car traveled to reach the ground, right? So now we know that from one of the equations of motion that s equal to ut plus half at square, right? We know the initial velocity is 0, so this would be 0 plus half. What is the value of a? A is the acceleration due to gravity, it would be 10, and the time is 0.5 square of that. So if I do that formula, I get s to be 1.25 meter. Okay, and that would be the, the how high the ledge is, or the distance traveled by the car. Now let's do one more example. So in this problem, they're saying that an object is thrown vertically upwards and rises to a height of 10 meter. So if this is my ground and then I throw an object from the ground, so it goes all the way up to 10 meter. Okay, then it's asking me calculate the velocity with which the object was thrown upwards. So I need to calculate what was the initial velocity which carried the stone all the way up to 10 meter. Okay, and then second bit is like time taken by the object to reach the highest point. So like, and how much is the time it takes to reach to the 10 meter height. Okay, now one thing which is clear is that the motion of this object is upward, and we know gravity x downward, right? So the direction of the acceleration of this object is negative because it is not in the direction of motion, as we discussed before. Okay, things we know, object traveled a distance of 10 meter. Okay, initial velocity, we need to calculate that. Final velocity, so that is what happens to the object when it reaches the height of 10 meter. Okay, now it is telling us that it rises to a height of 10 meter, and that's the maximum the object can go with the velocity we provided initial. So at the finally, object is actually stopping there and coming back, so the final velocity at that point is 0. Okay, because at that point object goes up there and then it starts coming down, so the change when that happens, that point, the final point, the velocity is 0. Okay, so now it is telling us to ask the velocity, right? So we know v square is equal to u square plus 2as. Okay, this is from our equations of motion, right? A, which is acceleration of the object, is actually negative minus g, right? So acceleration here, I'm going to say acceleration is equal to minus 9.8 meter per second squared, because acceleration is acting downwards and the motion is upwards. So now I can put like numbers we already have. So v square in final velocity is 0, so this is going to be 0. U initial velocity, that's the one I need to calculate, plus 2. A is minus 9.8 because it's acting downwards and the motion is upward, and the separation, which is 10. Okay, if I use all these values here, I get u to be 14 meter per second square. So this is the velocity with meter per second. So this is the velocity with which the object was thrown upwards, okay, and then to reach the height of 10 meter. Okay, the second part of the problem is asking calculate the time taken by the object to reach the highest point, which is 10 meter, right? So we know from our equations of motions that v equal to u plus at. And the reason I'm using this equation is because I know everything else on this equation now except time. Okay, so we know the final velocity is 0. Initial velocity we just calculated is 14. Acceleration we know is minus 9.8, and the time is the one we need to calculate. So if you calculate time by this equation, you get t equal to 1.43 seconds. Okay, so if you look at this problem, it's asking the velocity which the stone, we know it is 14 meter per second, and the time taken by the 1.43 seconds. Okay, so I hope these two problems gave you a little bit of flavor about free fall, how you take the sign of acceleration, how you apply equations of motion, which we learned in like earlier chapters. We can apply it here. So I would say, solve more problems, go to NCERT book, use other books, solve as many problems as you can, and then only you will get a feel of it.